Hello there. Welcome to this lecture on Chemical Engineering Economics, Part 1, Capital Costs and Costs of Manufacturing. You may have heard these terms being thrown around in chemical engineering circles: capital costs, total plant capital costs, fixed capital investment, and you may be wondering what they mean. Capital cost is a very simple term. It is not that complicated. It's just the cost to purchase equipment such as a pump or an entire plant, but it does not include the cost to run the equipment. So capital costs do not include steam, electricity, raw materials, and other ongoing costs. Fixed capital investment is also known as FCI. It is sometimes also referred to as total plant capital cost. It's the total cost of equipment and setup for a plant. So unlike capital costs, which could refer to the cost of purchasing one pump, fixed capital investment is a total plant capital cost. It's the total cost to set up a plant. This frequently includes land if land needs to be purchased and developed in order to put a plant on it. Which chapter in the Turton textbook discusses this? It's the Estimation of Capital Costs chapter. Your textbook might be a different edition from mine, so just look for the Estimation of Capital Costs chapter. Before we move on to costing an entire plant, we need to discuss some definitions that are very commonplace in capital costing. The first one is bare module cost, CBM. It's the cost of equipment plus the installation, shipping, insurance, taxes, engineering, and some overhead expenses involved with the installation of that piece of equipment. So in other words, it's the cost of purchasing a piece of equipment and installing it. The total module cost builds on the bare module cost. It is the bare module cost plus unforeseen costs and contractor fees. So this accounts for a lot of important fees. So it can account for the cost of having to delay the installation of a plant because of storms, bad weather, worker strikes, contractors quitting, changes in the design, unforeseen price increases. And so how do you account for this? You would pad the numbers by 18%. That is why total module cost is 18% higher than bare module cost. The grassroots cost builds on the total module cost. It is the total module cost plus the cost of land, auxiliary buildings, storage, utility supplies, environmental and safety systems, and you use the total module cost and the bare module cost at base conditions to calculate it. So grassroots cost essentially involves everything. It involves purchasing land, it involves developing the land, grading the land, installing sewer systems, roads, parking lots, administrative offices, maintenance, control rooms for the process, warehouses, cafeteria, locker room, medical facility, raw material storage, final product storage, loading and unloading facilities for raw materials and final products, all equipment necessary to supply steam and natural gas and cooling water and refrigerant, wastewater treatment, incinerators, flares, fire suppression systems. It includes essentially everything. So if you have nothing and you need to purchase land and put a process on it, the price that you are calculating is grassroots cost. If you are building on an existing facility that has many of these already set up, then you are calculating the total module cost. Okay, so the next step is we're going to use a piece of software called CapCost to determine the bare module, total module, and grassroots cost. And I will guide you through that, but the first step is to look at our equipment summary table, because the equipment summary table has a lot of useful information that we will need to price each piece of equipment in the process. So this is part of my equipment summary table. I will just do a few examples. You would do this for your entire process. So I will cost the reactor first. And so the reactor is made of stainless steel. It is a horizontal vessel. It's not a CSTR. It has an inlet pressure of 5.5 bar. That's 4.5 bar gauge because CapCost likes pressure in terms of bar gauge. The height is 6, diameter is 1 meter. For the tower, its materials of construction are carbon steel for the cylinder. It has an inlet pressure of 4.6 bar, that is 3.6 bar gauge, and this is the height and diameter of the tower. It also has 12 carbon steel sieve trays. For heat exchangers, some of you may not have heat exchangers in your system, at least not rigorous heat exchangers, and so you might not be able to price heat exchangers if you are using a non-rigorous heat exchanger, because a non-rigorous heat exchanger such as a heater or a shortcut heat exchanger does not provide you with area, and you need to have area in order to price a heat exchanger. But just to show you how you would input this information into CapCost, we will input all of this information, including area, the shell side, tube side materials of construction, and shell side, tube side pressure. We will also price a compressor that is a reciprocating compressor, stainless steel. It has a actual power, which is the shaft power of 101.5. This is not the theoretical power from Aspen or ChemCAD. This is the actual power accounting for efficiency. Lastly, we will price a centrifugal pump that is made of stainless steel and has a shaft power. This is not the theoretical power, this is the actual power. It has a shaft power of 15.9. So let's take all of this information and apply it to CapCost. Here on Google, we would do a search for CapCost software. And we're going to go to the website for your textbook. We're going to scroll down here, download CapCost 2017, and we will open it. Okay, there are a few things we need to do once it's opened. The first thing is to go up here over by capital cost estimation software, click on that. Then go to the left here with this red button. It says CapCost. We're going to click on that. That brings us to this pop-up, this software interface. The first thing that we do is we erase whatever information they gave us here. I don't know why they provide you with some already filled in information. I don't know what this is about or why this is here, so we're going to remove all equipment. Excellent. So now we have a blank spreadsheet, so we're going to start adding equipment. So let's start with our reactor. For the reactor, you might be tempted to go over here by reactors, and it's asking you, are you trying to price an autoclave, a fermenter, jacketed, agitated type of reactor? And you don't want any of those. This is a packed bed reactor. This is not a CSTR or a bioreactor. So we are going to get out of there, and we're going to go back to vessel, because really what you need is a horizontal vessel. That is a packed bed reactor. So we're going to choose vessel. We have a horizontal vessel. We leave this. This is fine. Our materials of construction for the reactor are stainless steel. We have no demisters. Diameter is 1 meter, length of 6. Maximum pressure, so our design pressure is 4.5. I'm going to put 5 bar gauge. And you can see that it's already populated some of this information. We're going to click on Finish, move this out of the way, and we see here that we have some prices here. This is important. So we have the bare module cost. This is the cost of this vessel installed, shipped and installed. The total module cost is the cost if you already have land and supporting resources. The grassroots cost is the cost if you essentially have nothing and you have to purchase land, develop it, build utilities, buildings, etc. So we have just priced our first piece of equipment. I'm going to make another change here. CEPCI is an index which accounts for the increased cost of equipment year over year, depending on the cost of metals and many other factors. And so for 2019, this number is around 607. So I'm going to update that. Notice that these numbers go up a little bit when I do that. And I'm going to change unit number to 500. And then this changes my vessels and my reactor and my tower to V501 or exchangers to E501, E502. Okay. So now we're going to add equipment again. Next, we had a tower, a distillation column. So our tower, the vessel itself was carbon steel. This is fine. We don't have demisters. We do have trays, they're sieve trays, and they are carbon steel. There are 12 of them, no packing. The diameter of the vessel is 1.6. Height is 9.8. Maximum pressure I have here is 3.6 bar. I'm going to round up to the next integer, which is 4, and you can see that some of this is already populated. So we now have our first tower specified here. Notice this is a bit more expensive. Next, we have a heat exchanger. So I will go here to heat exchangers. So S/T is shell and tube. Shell and tube. There are 2 varieties you can choose. The one in my equipment summary table is a floating head, so that's the one I will choose here. And the tube side and shell side materials of construction are carbon steel and stainless steel. They do not give me a choice here for carbon steel, stainless steel, so I'm going to choose stainless steel because it's better to over approximate than to under approximate. And I have here the maximum operating pressure for the tube side is 44 bar gauge. Shell side should be 5. Heat transfer area, 553. Number of shells is 1. And we've added our heat exchanger. Next, we're going to add a compressor. We have a reciprocating compressor that's made of stainless steel. The fluid power is 101.5. Number of spares we can leave blank. It's telling us that the specified power is too small for this type of compressor, so we should choose a different type of compressor. When our power requirement is this low, we should probably choose rotary. And notice that it auto-populated for rotary. So we will add that one. So now we have our compressor. Lastly, we have a pump that we need to add. This pump is centrifugal stainless steel. It has a shaft power of 15.9. Its pressure at discharge, I looked up, is 14 bar gauge, no spares. We'll finish that. So we now have added our pump. So you can take this information and then put it in your report or presentation. We can sum all these values to obtain FCI. So notice that I've performed the calculation for all the pieces of equipment in my process. I've summed the bare module cost, and then I've calculated the total module cost. This is also the software already calculates it for you, and then the grassroots cost is also calculated for you. Remember that if you are building a process on land and you already have access to steam, cooling water, fuel for furnaces, auxiliary buildings, offices, all of that, your fixed capital investment is the total module cost. If you are starting with nothing and you need to purchase land and everything else, you will be calculating grassroots cost. So if you are starting with nothing, that means you really don't need the total module cost necessarily. You shouldn't present it. Your final cost, your FCI, is the grassroots cost. Equally important to capital cost is cost of manufacturing, which is sometimes, many times, more expensive than capital costs. What is cost of manufacturing? It is all of the costs to keep a plant running and making product. This includes many, many, many costs. Most importantly, raw materials, which is the largest cost of running a process, steam, fuel, refrigerant, cooling water, waste treatment, operators, engineers, supervisors, maintenance workers, people who perform repairs, and the cost of repairs, all expendable operating supplies, quality control and testing, paying the lawyers for patents and royalties, operating those buildings with water and heat and electricity, local taxes and insurance, payroll and accounting, fire protection and safety, all medical services, cafeteria, locker rooms, other support facilities, the cost of employee benefits, the huge salaries and fancy buildings for all administrators, sales and marketing department, and of course we can't forget the people who have the PhDs and are doing research and development. Which chapter in the Turton textbook discusses this? It is the estimation of manufacturing costs chapter. What is the formula for cost of manufacturing? It's actually pretty simple, surprisingly. It is about 5 terms. It's very straightforward. So the first term is 18% of the fixed capital investment. This is either grassroots cost or total module cost. The cost of operating labor is described by this formula. N sub NP is described by this number of pieces of equipment, including reactors, towers, flashes, heat exchangers, furnaces, compressors, and turbines. So you sum up all pieces of equipment except for pumps and valves. The cost of utilities per year, you would use table 8.3 in your utility stream table to calculate. If you don't have a utility stream table because you've used shortcut columns, you can still calculate utilities. However, it should be the topic of a separate video lecture. The cost of waste treatment, you should use table 8.3, which provides you with costs of wastewater treatment, solid and liquid, hazardous and non-hazardous waste costs. The cost of raw materials, you multiply your inlet process stream flow rates by the price of the chemical. So you would take your inlet process stream, and that could be in units of kilograms per year. You would multiply it times the price of that chemical in dollars per kilogram. That gives you dollars per year. This is the price of your reactant.